Hello guys. Okay, in this problem we're going to consider a graph and see how to measure the quantities that are involved in a motion when we're given a graph. Okay, let's consider this problem here. It says the figure below shows the velocity graph of a particle moving along the x-axis. Its initial position is 1,0 meters. So which means at time equal to 0 seconds. So the position of the particle is 1,0 meters. Okay, you can see the graph here. It is the graph of velocity versus time. All right, so along the x-axis we have time there in seconds. Along the y-axis we have the velocity in meters per second. So the first question is to calculate the particle's displacement after t,0 seconds. Okay. So let's work it out together. So we're looking for the displacement. Okay, so this is, let's say, the solution. There is problem 1. Okay, so 3.1.1. So we have displacement. We're given a velocity time graph. So the displacement is the same as the area under the graph. Okay, so the change in x, we know that it is the same as x final minus x initial, which is the area. So the area here is the same as, the area is the same as the base times the height, because that area is takes the form of a rectangle. So we're going to have the position there, which is the same as initial displacement plus b times height. B times height. Okay. Let's say the initial position. Okay, as you can see, initial position is 1, and we are looking for the area between 2 seconds, between 0 and 2 seconds. Okay, or after 2 seconds. So we're talking about this area. We're talking about this area. This is the area that we're talking about, from here up to here. So you can see the displacement will be, the base will be 2 seconds, then the height will be 4 meters per second. Okay, let's work it out. Okay, so initial displacement is 1,0 meters. So the base, as I've mentioned, is 2 seconds. Then the height is 4 meters per second. Okay, let's work it out. 1 plus 2 times 4. So it should be 8 plus 1. It should be 9. 9 meters. So you can say, to write it in 2 significant figures, is 9,0 meters. Or you can just say 9 meters. Okay, let's go now to the second question. 3.1.2. 3.1.2, let's check what we are required to work out then. Okay, so 3.1.2 says the particle's acceleration between 0 and 2 seconds. Okay, so again, from here up to there. So we're looking for the acceleration. We're looking for the acceleration. Let's check how to go about solving it. So this is acceleration along x-axis, because we're given the velocity along x-axis, or the x component. Okay, so the acceleration in a velocity time graph is the same as the slope like the gradient of the graph. So she's going to be the same as y2 minus y1 all over x2 minus x1. So we know that along y-axis we have velocity, so it's going to be v final minus v initial. So since the object is moving at a constant speed, so it's 4 minus 4. Okay, 4 minus 4 meters per second over the time, of course, is 2 seconds minus 0 seconds. Okay, let's work it out. So this gives us 0 meters per second squared. 0 meters per second squared. Okay, let's go to the next question, which is 3.1.3. Okay, let me share the question again. Okay, so now we're looking for the acceleration between 2 and 4 seconds. Okay, let's work it out. Acceleration between 2 and 4 seconds. So as you can see, the initial velocity is 4, the final is 0. Okay, so let's work it out. As I've mentioned, acceleration in a velocity time graph is what is the same as the slope, which is y2 minus y1, which is v final minus v initial. So over x2 minus x1. Okay, y2, as I've mentioned, is the final velocity, which is 0 meters per second. y1 is 4 meters per second. Okay, let's check now. X2 is 4 seconds minus 2 seconds. Okay, let's check the answer here. It's 4 divided by 2 is negative 2 meters per second squared. So it's negative because the object is slowing down. So as you can see, the graph here, the object, as you can see, from this point up to this point, you can say that the object, the velocity decreases from 4 up to 0 meters per second. So whenever the object is slowing down, so which means the acceleration is negative, it's in the opposite direction. Okay. So now let's check the last question here is calculate the particle's displacement after 4 seconds. After 4 seconds, what is the particle's displacement? Okay, let's work it out. Okay, that is 3.1.4. Okay, so we can divide our graph. So we're going to have x, which is the same as x0, plus the area of the rectangle there, the area of the rectangle, plus the area of the triangle, plus the area of the triangle. So, okay. So this one, we worked it out. You know it's b times height. The area of a triangle is half times base times height. Okay, so the initial, of course, is 1,0 meters plus the base. Base times height, let's check the base of the rectangle there. Okay, as you can see, this is the base of a rectangle, which is 2. So we have 2 times 4 there. So we have 2 times 4. Okay, plus the base of a triangle is also 2. times the height, which is 4. Okay, let's work it out. So it's 1 plus 2 times 4 plus half times 2 times 4. Okay, let's see the answer. The answer is 13. 13 meters. That is the position. That is the position of the particle after 4 seconds. Okay, guys. Okay, let's go back to our notes. I hope you understood that. Okay. Let's check it. This activity. Please do it by yourself at home. Let me know if you experience some challenges so that I can help out. Okay, it says 3.1. The figure below shows the velocity graph of a particle moving along the x-axis. Its initial position is 1,0 meters. Okay, so as you can see here, we're given the velocity time graph. Along the x-axis, we have time. Along y-axis, we have the velocity meters per second. Okay, the first question says calculate the particle's displacement after 2 seconds. So after 2 seconds, some of them. Calculate the particle's acceleration between 0,0 seconds and 2,0 seconds. Then calculate the particle's acceleration between 2,0 seconds and 3 seconds. Okay, so this one is supposed to be 2,0 and 3 seconds. And 3,0 seconds. As you can see, this runs up to 3 seconds. So also this one, calculate the particle's displacement after 3 seconds. After 3 seconds. So it should be 3. Okay. Okay, guys, that is the end. Hopefully, by now you're able to calculate the quantities that are involved in a graph of motion. Okay, so if you're given, for example, let's say you're given now the acceleration time graph. So if you're given the acceleration time graph, where here we have acceleration, okay, and here, okay, let's say this one is given in meters per second squared, and here we're given time in seconds. Okay, so this is the graph. So now here, if you want to work out a velocity, you know, in an acceleration time graph, you need to know that in this case, velocity will be the same as what? Velocity will be the same as area of the acceleration time graph is equal to the area here. Okay. So it's the same as the area. Okay. So this is a rectangle, so which means we're going to have time there, which is the same as the base and the acceleration. So which means this will be the same as what? As the base, because this is a rectangle, times the height, which is the same as, in this case, it's going to be the time, whatever value of time is given there, times the acceleration. Times the acceleration. This is how it's going to look like. And then we can get the velocity of the object at time t. Okay, guys, thank you for taking part of the lesson. Hopefully you understood. Okay, thank you. All the best.